alloys are the homogeneous mixtures of two or more metals and non-metals. When two or more metals, okay, they combine together, they form alloys, okay. And in a homogeneous form means we can say that when two or more metals combine together, okay, they are not combining each other, they are mixed together in a homogeneous pattern, okay. So we say that they are forming alloys. So alloys are the homogeneous mixtures. These are the homogeneous mixture of two or more metals and non-metals, okay. For example, okay, for example, if I'm talking about that zinc, brass is an alloy of copper and tin, okay. Bronze is an alloy of
Sir, I think we did this.
copper and zinc. Copper and zinc. I know. Bronze is an alloy of copper and tin. Okay. So similarly, if we have solder, is an alloy of lead and what? Lead and tin. Okay, so they are different alloys. So why we are making alloys? So we are just making alloys in order to prevent it, or means for different purpose. For example, if we have two atoms like A atoms, A type of molecules, okay, and there's B type of another metal that is going to have B types of atoms. In the we have checked their properties that they like each other very much. They like each other. Means the force of attraction between AA and BB, okay, is not so strong as comparison to if we mix A and B. So if they like each other more, so we will mix them to increase the durability. Okay, we will mix them AB, 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 AB. So they will have more force of attraction, and this alloy is going to be have. We will say that it will be more durable. The second one is
yes.
Second one is if suppose we have A types of items, okay, and they are placed like this way. And due to distortion, one layer can slides over the other, and it may result like this. One layer can slide over the other, and it may result. So there is a this layer can slide, and this result in distortion of the shape. Okay, this may result in distortion, shape distortion. Okay, are you getting my point?
Yes, sir.
So if the one layer can slide, so what we will do if we put one here? If we put, let's suppose, if we put this one in between this one, okay, let's suppose if we place an atom which is in between this one, so they will not be able to slides.
Good evening, sir.
Good evening. So they will not be able to slides over one another. So this is because here we have just increased the durability of the metals. In this case, that we can say that if this is an atoms of iron, if these are the atoms of iron Fe, okay, if I'm saying that these are the atoms of Fe, iron atoms, and this is the atoms of carbon. So we did this in order to increase the durability of iron atoms. Okay, so Fe, there will be less distortion. Fe, and we add carbon atom in between, C carbon atom, so that this layer cannot slide over one another and will remain in its original shape. And this is called steel, not the stainless steel, only steel. With okay, so when iron is mixed with 1% or 2% of carbon, then it forms steel, which is very much durable. Okay, it does not distort, and this is being used for making heavy machineries and railway tracks. Okay, got it? Got it?
Yes, sir.
The next one is corrosion. What is corrosion? So this may be asked that what is the uses of alloys? So it may be asked in the examination. The second one is, let me explain you one more time that amalgam, there are different types of alloys. Okay, alloys are of different types. Okay, one type of alloy is amalgam. Amalgam. We'll say that amalgam is an alloy in which one of the constituent is mercury. One of the constituent is mercury. Okay, constituent is mercury. Okay, okay, like sodium amalgam. This is sodium amalgam. Sodium mixed with mercury. Okay, sodium amalgam. So whenever you see that amalgam, it means it is a alloy. Got it? Understood? The second one is ferrous alloys. Ferrous alloys. We will say that one of the constituent is iron. Okay, like steel, stainless steel. Steel. Okay, got it? Got it?
Yes, sir.
So what is the purpose of making alloys? Purpose of making alloys is that alloys are being used in order to get that metals or metals, a new metal, when we are just mixing two or more metals or metals and non-metal together, just in order to get some extra strength or to increase or decrease the melting or boiling points. For example, solder, which is an alloy, of lead and tin. So when lead atoms, this is Pp atoms, they don't like each other. They don't like each other. Sorry, lead and tin atoms. Tin is Sn. They don't like each other. We have checked the property that they don't like each other. So we will mix them together. When lead atom is mixed with tin atom, so they don't like each other. They will repel each other. They will repel each other. They don't like each other. Due to that, they can easily melt out. They can easily melt out because these atoms do not attract each other with a greater force. So because here A dislikes B, A dislikes B. Okay, so melting point will reduce. If A likes B, then melting point will increase. You understood? Understood?
Yes, sir.
Sometimes we require some alloys for making aircraft. Okay, so we use magnesium, we use magnesium and aluminum, we mix together. This is being used for making aircraft. Okay, that is more durable, stronger and lighter in weight. So we use alloys in order to make something, a new metals or a mixture of metals to get our desirable characteristics or hybrid form of that metal. Okay, you understood? Understood? Should I move forward?
Yes, sir.
Okay. Now moving to the next part is corrosion. What is corrosion? We'll say that gradually eaten up of metals by when it comes into contact with the atmospheric gases. Okay, we call it corrosion. So let me wait, give me a second. Okay, let me have the slide of this chapter of this topic. So we're going to have the corrosion. So what is corrosion? Corrosion is, we can simply say that when metals comes in the contact, when metals comes in the contact with some atmospheric gases or unwanted gases, okay, and it forms an unwanted layer of it, okay. So we call it corrosion, okay. The most important corrosion is, or most famous, not the important, famous corrosion is the corrosion of iron. We call it rusting. Okay, so rusting is the corrosion of iron. Okay, so what is corrosion? Note it down. The definition of corrosion. Note the definition. The deposition of unwanted layer on the surface of metals when it comes in the contact with the atmospheric gases. Note this definition, green color definition in your copy. I will check it after the class end whether you are writing or not. Note it down. Note this. Note this definition. Done.
Yes, sir.
The deposition of unwanted layer on the surface of metals when it's come in contact with the atmospheric gases like sulfur dioxide, carbon dioxide, or oxygen. So that is called corrosion. Okay. And the most important corrosion is rusting. Rusting. Okay. The rusting is the most important, or we can say that the most famous corrosion is of iron. So when iron comes in the contact with the oxygen gas and the water, then it will give you Fe2O3 dot X2. Fe2O3 dot XH2. This is the formula for the rust. Okay, so for rusting, because rusting is the corrosion of iron, we cannot say that rusting is taking place in aluminium. No, corrosion of the special name given to the corrosion of iron is rusting. Okay, got it? Got it?
Yes, sir.
So if I'm talking about rusting, it's corrosion of iron. Now moving to this part here is that for rusting, we need three important things, or three all of them things. Means iron should be there, oxygen should be there, and water molecule should be there. Okay, so the important condition for rusting is that all of them should be there. Okay, one is iron, the second one is oxygen, and third one is water. Okay, so if we have this condition like this, if we have airtight container and we are going to have only water in it, okay, then it will not rust. If we have airtight container having only air but no water, no moisture, only oxygen, then it will not get rust. If we have open and if we have water and oxygen in it, so it will get rusted. Okay, got it? Got it?
Yes, sir.
Yes, sir.
Yes.
So it is also the rusting will take place in the container C because it is requiring both water as well as oxygen. So for rusting, we need iron as well as water plus oxygen. Three of them should be there. Got it? Now, how can we prevent rusting?
Yes, sir.
How can we prevent rusting? So rusting can be prevented by creating a layer between the iron metals and the atmospheric gases. So if it is, this is main layer of iron, and if we are just creating a layer between the atmospheric gases O2 and this one. So if we are just creating the layer between them, so we can simply say that rusting will be prevented. Rusting can be prevented by creating means rusting can be prevented prevented by creating a layer between the iron surface and the atmospheric gases. And this layer can be prevented by, sorry, it can be prepared by using oil, grease, by applying paint, by applying a thin layer of some other metal. For example, this is the iron main layer, Fe, and we just coat it with the zinc layer. So zinc is acting here as a protective layer. It will not allow the oxygen and other gases to react with iron to come in the contact with the main layer of iron. So it will prevent it. So we can say that it can be done by the following ways: by applying paints, by galvanizing. What is galvanizing? The deposition of thin layer of other metals, or okay, like zinc, tin on the surface of iron. So what we do is we take the iron metal and we just drop it into a molten zinc or something, and we just pour it into the iron and then keep it out. So a thin film of zinc metal comes over the and comes into contact with the iron, and then it can be melted. Okay, so by greasing, by burning, and by making alloys. Got it? So take the screenshot of this. You have to write it down in your copy later. Done?
Yes, sir.
Abdullah, Adil, Hiba. Done? Karishma, done?
Yes, sir.
Done, sir.
Yes, sir.
Next is copper when react with atmospheric gases, corrosion of copper. Corrosion of copper. So if I'm talking about the corrosion of copper, if you have copper, when it comes in the contact with atmospheric gases, so it forms copper hydroxide dot copper carbonate. CuOH voltage or copper carbonate. This is the rusting up, and it is greenish color. Black, or we can say that dirty green color layer is formed over the copper. Okay, greenish black color, greenish brown layer. Okay, so it is an hydroxide or a carbonate here. So when you apply simply when you wash it with mild acid like citric acid or some lemon, so this layer of correct layer will deplete and dissolve, and the fresh new layer of copper comes outside. So we can say that if you wash it with, if you are having a copper utensil and it get corroded by this layer, so wash it with mild acid like citric acid, like lemon. Okay, so that is present, okay, in the lemon. So if you wash it with lemon, then it can be, this layer will easily dissolve. So when you apply lemon over it, so this layer can be dissolved, and we can say that the corrosion can be easily prevented. Okay, means not prevented means fresh layer of the copper will come from outside. Okay, got it? So note it down. Copper is important. Copper hydroxide, copper carbonate. This is very important. Note it down now in your copy. Green colored layer deposited on the surface of copper and come in contact with the atmospheric gases. Note it down. Done?
No, sir.
Noted.
Done, sir.
The question, important question. A brown colored substance X, when comes in the contact with the atmospheric gases, forms another compound Y. The compound when rubbed with mild acid like citric acids, its surface get brown. Find X and Y. Note the question. Done?
Yes, sir.
No, sir.
Note it fast. Done? Imba done?
Yes, sir.
Karishma? Done?
Yes, sir.
Okay. Now moving to the next part is silver. Silver when get corroded, it form a black layer of silver sulfide. Okay, this is black colored silver sulfide. Silver sulfide. And it can be prevented when you heat it. You know that when you heat it, it's Ag in the presence of oxygen. So it will simply roast it and it will gives you Ag plus O. Got it? Ag plus AgO plus SO2. And further when you keep on heating it, it will gives Ag plus. So when you further heat it, Ag, that will gives you Ag plus O2. So when you heat it, simple silver sulfide, the black layer will be removed when you heat it with the help of oxygen. Okay. Okay. So when you heat it, it will
Yes,
react
sir.
with the atmospheric gases and will gives you Ag2O, and then on keep continuous heating, it will get converted into silver. Got it? Understood? So this is
Yes, sir.
black. This is black color. Okay. And one important thing is that this is the rusting of copper. So let me write it. Rusting of iron is Fe2O3 dot X is 2. Rusting of copper is copper hydroxide dot copper carbonate. Rusting of aluminium is, sorry, rusting, not corrosion. Al2O3, okay. Of aluminium is Al2O3. That of silver is AgS. Got it? These are the important. And this is black in color. This is black, dull color, dull aluminium, greenish color. And this one gives you brown, reddish brown, reddish brown color. Got it? Note it down. Copper when heated, it will react with atmospheric gas and will give you Cu2O. Okay, so it is being asked as a compound X when heated. Okay, heated. It will give you a black color compound. This brown. This is brown in color, and this is black in color. So I'm going to show you the question that is being asked for this exam in the examination for this topic.
Done, sir.
This type of question is asked in the examination. A shiny brown color element X on heating becomes black in color. Name the element and name the element X and the black color compound formed. So what is question number 17? I'm talking about question number 17. What should be the answer for this question?
X is copper and the element form is CuO. Cu2.
Copper oxide, okay. And it can be again, if you
Further heated CuO.
yes, it can regain
Cu
its
plus
original. No, when you heat it with carbon or some other metal, so it will give you Cu plus Cu2. So again, you will get this back. Okay. Got it?
Yes, sir.
So this question type of question may be asked in the examination. Next type of question that you going to ask in the examination is so on the rusting, there may be so many other questions that can be asked in the examination. Okay, so you need to keep in that you have to learn and for example here question number. The reactivity of air decreases if it is dipped in HNO3. Why? Why? Question about this because HNO3 is a strong oxidizing agent. Okay, and it will form aluminium oxide, and aluminium oxide is actually a protective. So let me do it here that aluminium when react with atmospheric gases, it forms Al2O3, and it is a protective layer. Protective layer. It acts as a protective layer which further do not allow the aluminium to react it further. Okay, so it forms a protective covering over it. For example, this is an aluminium metal. Okay, so if it is reacting, so when it reacts, then it forms a protective layer of Al2O3 over it, and it comes in the contact with the atmospheric gases. Got it. and it will not allow further to react with the main layer of aluminum. So Al2O3 is a protective layer. So when it reacts with HNO3, first of all, HNO3 do not react with aluminum. HNO3 only react with manganese and magnesium to liberate out hydrogen gas. Moreover, if it react, then it form Al2O3, aluminium oxide, okay, or aluminium nitrate, which further means we just simply need to answer that HNO3 is a strong oxidizing agent, which oxidize the hydrogen gas to water, okay, and itself get reduced to HNO3. So means this reaction is slow because HNO3 is a strong oxidizing agent. It oxidizes the aluminium, okay, and it acts as a protecting layer. N23 act as a protecting layer, okay, got it? Got it? Next one is carbon cannot reduce magnesium and sodium. Tell me why carbon cannot reduce the oxide of magnesium and oxygen. Sorry, magnesium and sodium. B part 61, question number 61, B part. So in your copy that you have written that in your copy you have written like this. I have given you the table like this way. This is sodium, this is magnesium, sorry, this is potassium, then sodium, then calcium, then magnesium, then aluminium, then we have magnesium and manganese, then we have carbon, and then zinc, iron, tin, lead, and hydrogen. Okay, then hydrogen. We have zinc, iron, tin, lead. Okay, so these metal oxides are reduced with carbon. These metal oxides are reduced with aluminium, and these are reduced by electrolytic reduction. So since why it is not able to, because carbon is less reactive than sodium, so it will not be able to, if it is, we are going to have Na2O, carbon can react with Na2O, so it will not form Na plus CO2. Why? Because carbon is not, means carbon is less reactive than sodium, so it will not reduce, okay. But if it is zinc oxide, if it is iron oxide, then it reacts with carbon, then it gives you Zn Fe plus CO2. You understood what I'm saying? What I'm saying? Charisma, Hiba, Abdullah,
Yes, sir.
Karishma,
Yes, sir.
Adil, you understood? And Fazal,
Yes,
Fazal?
sir. Yes, sir.
So it will not reduce. Next question. NaCl is not a good conductor of oxygen solid state, while in the whereas it conducts oxygen in aqueous as well as in molten state. C part. What should be the answer for question number is for C part? Tell me. Because in NaCl, which is an ionic solid, there is a strong force of attraction between the positively charged ion. That is called electrostatic force of attraction. And this electrostatic force of attraction will not allow the sodium and chloride ion to move freely. So they are not able to conduct electricity. You can simply say like this. You understand?
Yes, sir.
But when you are having this one in molten and aqueous state, then this NaCl will get is free to move in the form of ion. Like Na and Cl can move because in molten state the ions can be easily movable, so they can easily conduct electricity. So we have written this one, this question, the answer for this question in your notebook. Iron articles are galvanized. Can you answer this question? Iron articles are galvanized. Okay, they are galvanized just because iron galvanization is the process of depositing a thin layer of metals on the surface of iron. Okay, so what is the rule? Why we are doing this? In order to prevent it from rusting. Means in order we are just creating a barrier so that the atmospheric gases cannot come in the contact with the main layer of iron. We are just preventing it. So galvanization, iron articles are galvanized because when iron is galvanized, then a layer of metal, other metal is comes in the contact between the atmospheric gases, and it will not allow them to comes in the contact with the iron, and thus prevent it from rusting. Okay, you understood?
Yes, sir.
Adil, you understood? Abdullah, you understood why they are galvanized?
Yes, sir.
Okay, next is metals like sodium and potassium, calcium and magnesium are never found in the free state in nature because they are
Because they are highly active metal. If they comes in contact with oxygen, it will cause accidents.
well, they are highly reactive metals. They are generally
Yes.
they are not found in the reactive state, native state, because they just always want to be combined states in order to attain stability. If one or any one. Question number 26. What will be the answer for question number 26?
The B.
Alloys are the homogeneous mixtures of metals with metals or a non-metal. The following contain a non-metal as an other constituent.
So
Non-metal.
B.
Bronze. That's why you need to know.
Acha, okay, sorry. For 26, 126. Okay, I didn't see.
For the 26.
Yes, question number 26. Right.
Amalgam, sir. Amalgam.
Not amalgam.
Sir, is it steel?
Yes, it is.
It is steel, sir. It is steel. Sir, it is bronze or steel.
It is steel.
Because like brass has, because brass has copper and zinc, and what do you see? Amalgam has like mercury and anything else. Bronze is like copper and tin. So I guess like steel.
Yes, steel is the correct answer. That is copper and iron and carbon. Okay, this was I was giving example of that iron atoms are this big in size. Okay, so to prevent it more durable, we just as compared to the iron atom, the carbon atom is small in size. So we just place the carbon atom, and carbon atoms comes in the voids in the space between these atoms. This is the carbon atoms. So it will not allow to dislocate the slides from one atom over the other, or one layer of atom over the other. This results in distortion, so it prevents it. Okay, so it becomes stronger. Got it? Understood?
Yes.
Yes, sir.
This we have done. Let us start. Let's check whether. Okay, question number 16. If copper is kept in open air, it slowly loses its shining brown surface and gains a green coating. It is due to the formation of.
Sir A, sir. Sir A.
Yes.
Sir,
A.
copper sulfate. Copper sulfate.
Yes, sir.
Yes, Hiba, what's your answer?
Yes.
Sir, it also happened with same thing like it happened in America like with Statue of Liberty. Before it was like shining brown surface. Now it's like it has turned green.
is copper carbonate, not copper sulfate.
Huh?
Copper carbonate, not copper
Yeah,
hydroxide.
how?
I have written this one. Can you copy that? This is copper carbonate, not copper hydroxide. So if it is forming carbonate layer, got it? Got it? I can check this question. Wait a minute. If you are having so, but I'm sure that it is going to have copper carbonate. Because carbonate layer and copper hydroxide layer are going to form. Okay, so if it is not written copper hydroxide, then it's okay. Carbonate is written here. Okay. Okay. So the correct answer is copper carbonate. Got it? Copper carbonates. I have written recently. We are discussing that when a copper comes in the contact with the atmospheric gases, then it forms a layer of copper hydroxide and copper carbonate. So copper hydroxide is not written that. Let's say it's okay. It is copper carbonate. You should give preference to copper carbonate. Okay, got it? So note down this question in your copy and write the answer for this one. Done?
Yes, sir.
Yes,
Next
sir.
one. Next one is stainless steel is very useful metals in our life. In stainless steel, iron is mixed with question number 15. Question number 15. Note down the configuration of iron. Note down. It's in stainless steel we use iron. Only steel. If it is steel only, okay, then it is carbon. 1% carbon. Okay, and iron. Iron plus carbon. But if it is stainless steel, then we use iron, then carbon, then chromium, nickel and chromium. Okay, so we are using this iron, carbon, nickel, and chromium are the constituents of stainless steel. Note it down. Only steel, iron, and carbon. And in stainless steel, we are going to have iron, carbon, nickel, and chromium. Done?
Yes, sir.
So here's a question. Question number 4. So which is the correct answer for this question? Question number 14. 15, sorry.
A.
A, nickel and chromium. Yes. Next, question number 14. Answer for question number 14.
Think
What's which question?
Question number 14.
14. Sir, zinc.
Zinc.
Yes, sir.
Galvanization is a method of protecting iron from rusting by coating with a thin layer of zinc.
Yes, it is sure. Yeah, you are sure. Very good. So this is zinc. Next. Question number for 13.
Silver used from black and prolonged. Sir, Ag2S. Sir, C. Silver sulfide.
So we have discussed this one, that it is silver sulfide. Okay.
Yes, Ag2S. And then metals are refined by using different methods.
So we have
Achha.
discussed these all metals. Okay.
Yes.
Okay. Next question number 5.
Sir, I guess Fe3O4.
Fe3O4. Yes, Fe3O4. Good. So this chapter is finished. Let's start the new chapter, that is carbonates compound.
बहुत hard is chapter.
No, it's very easy.
Sir, it's like very lengthy first of all, and
Not so lengthy. It's easy. It will take a month to complete this chapter with some extra classes.
Yes.
Okay. So if I'm talking about this one, that in carbons compound chapter, first of all, I'm talking about that why we are studying the carbons compound chapter. Why not we are studying the other like aluminum its compounds. Okay. Like we are going to have the silver and its compound and gold and its compound. But why we are especially studying the carbon and its compound? It is due to some specific reason. Okay. First, note it down that in
There are
atmosphere.
more than 3 million compounds existing on Earth.
Yeah, there are more than 3 million compounds are present on the Earth. Okay. So let's talk first of all that the carbon in nature exists in atmosphere in the form of carbon dioxide and its percentage is 0.03%. And in earth crust, it exists in the form of coal and petroleum, and that is 0.02%. So note it down. Note it down.
So we have to write this also like chemistry, physical chemistry, or inorganic
No,
chemistry,
no, no,
organic.
no. This portion only.
Okay,
That
so this one minute, sir.
Then
Check. The next one is why carbon is so versatile in nature. So let me explain you that when we are going to have carbon is the first element that is going to have 4 electron in its outermost shell. Okay. The next element will be silicon, and that is also going to have a 4 electron in its outermost shell. Okay. So we're talking about this one is that carbon is the first element that is going to have the, if we do the electronic configuration, so why carbon is so versatile in nature, let me discuss. First is that it is going to have, it is tetravalent in nature. It is tetravalent in nature means, what does it mean? It means that it is going to have the 4 valency, so it can make bond with 4 similar or dissimilar atoms. Okay, or 2 dissimilar atoms. Same, dissimilar. Okay, so like at the same time. So because of the tetravalency, it can make bonds in double bonds. Okay, like this. So there are different types of being. Means we'll say that carbon is the first element that is going to have the 4 electron in its outermost shell. The other elements either have 1, 2, or 3, or 5, 6, 7, 8. So don't think that nitrogen is going to have 5 electrons in its outermost shell, so it can make bond with 5. It need to complete its octet, so it required only 3 electrons for bonding. It for 5 already have, so it will make bond with 3 atoms. Like this is hydrogen, this is hydrogen, okay, and this one is hydrogen. So they will make bond it like this way, 3 hydrogen atoms, and now it will complete it like this way. So we'll say here that it will make bond with maximum 3. In order to complete its 8, it will make bond with maximum 2. To make it bond with to complete its octet, it will make bond with maximum 1 atom to make its octets. But carbon can make bond with 4 atoms at a single time. So it is tetravalency helps the carbon to make it. Okay, got it? Understood? Understood?
Yes, sir.
The second one is that it is we can say that it is small in size. And what is the small, what is small size is going to help you? So small, due to small in size, the effective nuclear force to a bonded pair of electrons is more. For example, if I'm just talking about this one, and this atom is in the center of this is nucleus, and this is going to have 4 electrons in outermost shell. This is the carbon atom. Another atom we're talking about is silicon, right? This is silicon atom. It's going to have 2 in the first shell, 8 in the second shell. Okay, so it is going to have 8 and the next 4 in the other shell. So since silicon is going to have more size, okay, then it is going to have electron configuration 284. It is going to have 2, 4 only. So the bonded pair of electrons in hydrogen is nearer to the nucleus. They are nearer to the nucleus, so they can be easily pulled up with this one. Okay, means the force, the electrons can be held by positively charged species, that is nucleus. But here they are far away, far away. The bonded pair of electrons in silicon is away from the nucleus, approach. So the bond is not so stable. Bond is not so strong. Okay, got it? Got it? Understood? Due to first reason is tetravalency, second reason is small size. Due to small size, the effective nuclear force in carbon bonded pair of electron is more. Okay, this had to make stable bond or a stronger bond. Okay, so please first note down tetravalency. The first reason why carbon is so versatile in nature, the first reason is tetravalency. It has 4 valency, it can make bond with 4. Don't make it, okay? Don't make it. This is just for explanation. Note it down.
Done, sir.
Yeah. Note this one also. Small size. Done?
Yes, sir.
Okay. So the next two property, that is catenation and covalent bond, we're going to discuss in the next class. So note the topic that I will going to teach you in the next class is catenation property. Okay. Sorry, covalent bond.